So imagine we need to solve this equation, cosine of x equals 1/2, right? So what we want to do is we want to find all of the x values so that when we plug it into the cosine, that gives us 1/2. Okay, so for example, what would be 1? So like pi over 3, right? If x was pi over 3, I put it in here. Cosine of pi over 3 is 1/2. Okay? One thing we could do that to see it more clearly is if I have a graph of the cosine over its entire domain, negative to positive infinity, and I draw a vertical line at 1/2, right? So I want cosine of x to be equal to 1/2, meaning y values have to be 1/2. So if I have my graph over the entire domain of cosine, right? And if I were to draw a horizontal line at y equals 1/2, all the points where the two cross are my solutions, right? So I have one solution at x equals pi over 3. Is that right? Because cosine of pi over 3 is 2 pi. Is 1/2. So now, from pi over 3, right? So here's pi over 3. If I were to go around the circle another 2 pi, right? I would land back in the same spot, right? And I would still get a cosine of 1/2. Is that right? So on this, here is my pi over 3. If I were to go over 2 pi, I would land right here. That's also a solution for this. From the pi over 3, if I went back minus 2 pi, that's another solution. And I could go an interval of 2 pi in either direction, and I would get all of the points, and all of them would be a solution to this, right? So there are infinite numbers of solutions. One way I could show that is, I say, oh, x is pi over 3 plus 2 pi times n, right? And what does that mean? So plus n is any integer. So pi over 3 plus 1 times 2 pi, 2 times 2 pi, 3 times, or in the negative. Pi over 3 plus negative 2 pi, negative 4 pi, negative 6 pi, and so on. So that's one way I could write my solution. Where else is cosine equal to 1/2? Remember, cosine is equal to 1/2 here as well, right? So that's 5 pi over 3 right here. Now, from the 5 pi over 3, if I went over 2 pi, I have another solution. If I went back negative 2 pi, I have another solution. So another solution is 5 pi over 3 plus 2 pi n. You can write 2 pi n. It's more conventional to write 2n pi. All right? So here is another way of writing our solution. So x is pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. Quick, yes? But n is an integer. N is an integer that's either plus or minus 1. Right. So here we go. We're going to solve these equations now. The first point is to isolate the trig function. Right? So we're going to subtract 2 sine x. So here I get 2 sine x equal to root 2. I'm going to divide by 2. So sine x is equal to root 2 over 2. And so now I ask myself, for what, isn't that cool? For what values? Where is sine equal to root 2 over 2? That's like 1 over root 2. So where is that?
45 degrees.
Right. So at the pi over 4, where else? 3 pi over 4 here. Okay? Yes. So now we're going to do that x is equal to pi over 4 plus 2n pi, 3 pi over 4 plus 2n pi. Okay? Yeah.
Why can't you like put those both in the same like?
No, because
If you said pi over 4 plus like.
but okay, so you can't do that because you can only do that if there's a 180 in between here, okay? Because there is not an equal distance from one to the next.
4 plus 90 degrees.
And that's where it ends. Because if you do pi over 4 plus 90, it gets you here, right? But then if you do plus 90 again, it doesn't go back there. So we'll come across examples where you can do that. Yes. Wait, Tal first. Because sine is only positive in these two quadrants. Here we're looking for sine equal to positive root 2 over 2. Let me do a couple and I'll take more questions. One more.
I was just going to say, like, if it was negative.
Right, so let me do a couple. Yes, okay.
It has to be positive?
Okay, let me do this one. 3 cotangent squared x. We're going to subtract 3 here is equal to 3. Okay. So now divide by 3, divide by 3. Cotangent squared x is equal to 1. So now when I take a square root, okay, cotangent x is equal to what?
Plus or minus.
Plus or minus 1. So now take a look. I have two equations. I have that cotangent x is equal to 1. Cotangent x is equal to negative 1. So where is cotangent x equal to 1? At pi over 4 and 5 pi over 4. Is that right? So here we have pi over 4 and 5 pi over 4. I'm not writing the complete answer just yet. Where is cotangent equal to negative 1? 3 pi over 4 and 7 pi over 4. Now, how to write this? In regular pre-calc, we could say, okay, pi over 4 plus 2n pi, 5 pi over 4 plus 2n pi, this plus 2n pi, that plus 2n pi. But look at how often these repeat. How many degrees is there between pi over 4 and 3 pi over 4? 45 in here. How many degrees is there? 90 pi over 2, right? If this is 45 and that's 135, there is a distance of 90 between 3 pi over 4 and 1 pi over 4. The distance is 2 pi over 4, which is pi over 2. So there is a 90 degree, there is a pi over 2 distance here. How much distance is there here? Pi over 2. There is another pi over 2 here. There is another pi over 2 here. So, how do you get from one to the other, to the other, to the other? You're adding pi over 2's. So then, the answer here will just be pi over 4 plus, not 2 pi n, but pi over 2 times n. Okay, so now, let me say a couple of things here. How do you know? Look at this. There are 4. Oh, sorry. There are 4 angles. They're divided equally, right? So this circle is divided equally into 4 angles. So each must be 90 degrees, right? So you always have to go, okay, how do you go from one to the other, to the other, to the other? By adding pi over 2. Here, we couldn't do that because it's, however much here from pi over 4 to 3 pi over 4, but you don't have the equal distance to go back to pi over 4. So we had to do them separately. When the divisions are equal between all of the angles, then you have to combine them into this. Okay? All right, we'll do more and we'll see what it's going to look at. That's it right there. Okay, here we go. This one here, okay, first of all, let's figure this out. It says find the solution of the equation over the interval 0 to 2 pi. That means only one cycle of the unit circle. So you're not going to do plus 2 pi n or whatever. Okay? So we eliminate plus 2 pi n. Okay? When it says this. All right. Take a look at this equation. You have a sign here. You have a sign there. What do you think we should do? Okay, hang on. If we divide, you're getting rid of the sign. But you can't just get rid of information. When you get rid of information, you're eliminating possible solutions. So, never divide. What we want to do instead is this. And dividing is like the first instinct that everybody gets. What we want to do instead is this. Bring this term over here. So minus root 3 sine x is equal to 0. Now we can factor. We can factor out a sine x, and this becomes 2 cosine x minus root 3 is equal to 0. Now, when you have a term times another term equal to 0, you can split up your equation and do sine x equals 0, 2 cosine x minus root 3 equals 0. Please note, I know I don't have to say this in this class, but please note that if this number is not a 0, you can't do this. If it was sine x times blah, blah, blah equals 2, you can't do sine x equals 2 and then the parentheses equals 2. The reason why we can do this is called, you learned this in Algebra 2, this is called the zero product property. If that's not equal to a 0, please don't set them equal to 0, to like some other number. Okay, so now here, for what values is sine of x equal to 0? Well, if we're on the unit circle, sine of x, that's the y. It's equal to 0 here and here. So x is 0 and pi. This one is another mini equation that I need to solve. So 2 cosine x is root 3. Cosine of x is root 3 over 2. Another cute little, special angle identity that we know. So now, where is cosine of x? Positive root 3 over 2. In this quadrant and in this quadrant. And that's the pi over 6's, right? So x is pi over 6 and 11 pi over 6. And because we are only looking over the domain 0 to 2 pi, we don't have to do plus 2n pi or whatever. So these are our answers. It's convention that we write the answers in increasing order. That's convention. I won't take points out, but it's convention. So x is 0, pi over 6, pi, 11 pi over 6. Okay. Yeah. Look at this one. We have 4 terms. First of all, we can't even start doing anything unless everything is on the same side and this is set to 0. So 4 cosine squared x plus 2 cosine x minus 2 root 2 cosine x minus root 2 equal to 0. When you have 4 terms, it's best to see if you can factor by grouping. So we split it down the middle. Hang on. So from here, from the left side, we can factor out a 2 cosine x, and I get 2 cosine x plus 1. Here, I can factor out a negative root 2, and I get 2 cosine x plus 1 equals 0. Oh my gosh, I have the same term. We're going to factor out that term. So this is 2 cosine x plus 1 times 2 cosine x minus root 2. Okay, we're going to go back to our algebra days for this one. Now, I have 2 terms. They're multiplied, and it's equal to 0, zero product property. I can set this equal to 0 I can set this equal to 0. So 2 cosine x is equal to -1. Cosine x is -1/2. So now, cosine is negative in these two quadrants. For what angles is cosine equal to 1/2? The pi over 3's. So that's going to be 2 pi over 3 and 4 pi over 3. The next one right? Cosine x equals root 2 over 2. What angles are those? The pi over 4's. But now it's positive, so we go in the positive quadrants for cosine. So x is pi over 4, 7 pi over 4. Okay? Yeah. Correct. So you have to look at the equation. So you have to look at this equation, right? And if cosine is equal to a negative number, then you have to go to the negative quadrants. If it's a positive number, then the positive. So remember here, 4 terms, factoring by grouping. All right? Okay. So this is why we learned section 1. This is why, because you needed to apply the identities in order to solve them. We haven't applied too many identities yet, but look at the next section using trig identities to solve equations. Okay.
What are trig identities? Just doing that.
So that's section 1 that you missed. Okay. So section 1. Okay, again, we're going to apply the identities in order to simplify some of these. So again, it says find all solutions over the interval 0 to 2 pi. So when it's 4, so the only thing that's different if it says 0 to 2 pi is that don't put the plus or minus 2 pi in. Okay?
Doesn't matter if you write 2 and pi.
It's really 2 and pi. Yeah, okay. So here we go. What I have here, first of all, this is what should set you off. What you have here is a cosine and a sine. We don't want that. We want homogeneous equations where they're either all sines, all cosines, all cotangents. So first of all, we need to rewrite. So there's one type of function. Now, so then you look at this and you're like, okay. Another clue, the biggest clue here is that you have the square of a function. You have sine squared. The minute you see that, you're like, okay, I can work with that. The minute you see a sine squared, cosine squared, tangent squared, the first thing that should come to your mind is Pythagorean identity. Okay? So, sine squared x, use a Pythagorean identity. Okay, the biggest Pythagorean identity, the most famous Pythagorean identity is sine squared x plus cosine squared x is equal to 1. Now, I have sine squared x here, so I can always rearrange these so they can fit the mold that I want. So when I bring the cosine squared over, I get sine squared x is equal to 1 minus cosine squared x. So here, I'm going to substitute that. So here's what's going to happen. I leave the beginning unchanged. 2 times. Now I put in, for sine, 1 minus cosine squared x. Because I want to get rid of the sign and instead put in cosines. So now look, my equation only has cosines. Well, either, but I can't change this. I only have an identity for the sine squared. I don't have an identity for the 1 minus cosine. You see it? Okay. So 1 minus cosine x is equal to, when I distribute, 2 minus 2 cosine squared x. Now what? One specific thing we're going to do. Move everything over and set it equal to 0. Always. Okay? So 2 cosine squared x minus cosine x. Now here I do minus 2, so what is that? I'm bringing everything to the left. So plus 2 cosine x plus 2. I'm moving everything on that to that side. Negative 1 equals 0. All right, so bring everything to the other side. Okay. Huh? Can you take out a cosine? This one, you need to factor like this. So if you had 2x squared minus x minus 1, you would know what to do like this, right? You would just say, oh, that's 2x and x and 1 and 1, and where does the negative go? Here? Is that right? No? Yeah?
That's right.
Yeah?
That's definitely right.
Okay, so these things, it should be like almost like a reflex. So we know exactly what to do if it's 2x squared minus x minus 1. This is the same, except instead of the x, we have a cosine. So instead of saying 2x and x, we say 2 cosine x, 1, 1, plus minus. Why did we do this? Because now, zero product property. Two things multiplied equal to 0. I could set each of them equal to 0 separately. 2 cosine x plus 1 equal to 0. Cosine x minus 1 equal to 0. Cosine x equals to negative a half. Cosine x equals to a 1. Okay, cosine is equal to a half for the pi over 3's. But in the negative quadrants, that's 2 pi over 3 and 4 pi over 3. Where's cosine equal to a 1?
0 and 360.
At 0 and
180.
that's it, right? Just not, is it equal to 1 at pi? No. So just at 0. Remember, this only goes from 0 to 2 pi and doesn't include 2 pi. So then we're at 0, 2 pi over 3, 4 pi over 3. Okay? All right. Oh my. What about this one? What do we do first? Move it over. Okay, how many terms? 4. What do we do? Factor by grouping. See that? You're already seeing a pattern. This is one term, it's multiplied. 2, 3, 4. Okay. From the left, I can factor out a cosecant squared x. And I have cotangent squared x plus 2 minus, oh my God, look, cotangent squared x plus 2. Okay, isn't that cool? So now, where is the common term? Here, write that off to the side. What's left over?
Cosecant squared x minus 1.
Thank you.
And you have to difference of square.
Not difference of squares.
Cosecant squared minus 1 is
But we don't need it because look, zero product property, right? Now I have one term times another term equals 0. I could just set it equal to 0. Don't overcomplicate things. So let's set it equal to 0, and meanwhile, I'll take this question. Yes? Here? No, you factor it out. You write it once because we're factoring it out. Yeah. So look at this one. Cotangent squared x equals to what? -2. And does that work? Can you square something and make it equal to a negative? No, because when you take a square root, it's going to be the square root of -2. So no information there. Here, cosecant squared x equals 1. Take a square root. Right. Cosecant of x is equal to plus or minus 1. So now I need to look at where is cosecant of x equal to 1 and where is cosecant of x equal to minus 1. So now look, cosecant is like the buddy of the sine, right? And we want to see where sine is 1 and where sine is -1. Sine is 1 at pi over 2. Sine is -1 at 3 pi over 2. So x is pi over 2, 3 pi over 2. So at first glance, a very intimidating, anxiety-ridden problem. What do? You literally divide and conquer. Literally, we divided and you conquered. That's it. Okay? We take it in morsels. Yeah. First and foremost, in this one, you have different types of functions, but we want to make it all the same function. But then, okay, so we use identities to do that, but all the identities are with secant squared and tangent squared and da-da-da. Okay, in math, you're allowed to do anything that is mathematically correct. So, you want squares? Square both sides. Okay? So now, just be careful that you don't do secant squared plus 1 here, right? Because this is 3 terms. Secant squared x plus 2 secant x plus 1 equal to tangent squared x. Because it's a plus b squared, you have to get 3 terms. A squared plus 2. Guys, this is algebra 1. Okay? Now, secant, too many things are secant. Too many things to change the tangent. There was only one tangent. We might as well just change the tangent into 1. So, suppose you forgot what the identity was. What would you do? You would derive them, right? Okay, so what is this identity with the tangent squared x? Tell me. Correct. Okay? So, tangent squared x then is secant squared x minus 1. Correct? Identity, last lesson. So, oh no. Wait. What's happening? All right. So, secant squared x plus 2 secant x plus 1 equal to that. Okay, what happens to the secants? They cancel.
Yes.
Yes. So now, what I'm going to do is add 1. So 2 secant x plus 2. I should have done it the other way. What's secant x then? Just -1, right? So secant of x is -1. So secant, again, the buddy of the cosine. Where is cosine equal to -1? That's the x-axis at pi.